and problem solving are essential 21st century that equip learners in challenges, make sound judgment, and innovative solutions. In today's world, rapid changes and uncertainties are constant. The abilities to assess the skills has become crucial in education and personal development. Good morning, everyone. I am Donna Chingdi Pata, and today I am going to show you three videos from different countries that shows how effective assessment, critical thinking, and problem solving is. Thank you.
Critical thinking skills and examples for kids. Today, we are going to practice using our critical thinking skills to help solve a problem. Just as a review, critical thinking means using your experience, knowledge, and creativity to solve complex problems. And here is an overview of the steps that we can use to help us. Okay, now let's put these skills to good use and help our friend Tyler out. Tyler has a problem. His teacher had given him an assignment to write the name of the sports his classmates play next to their names. But Tyler did not take great notes. So, he has to remember what sports 4 of his classmates, Bill, JK, Lisa, and Susie, like to play. The worst part? He cannot ask them again because all of them are on a field trip. What a bummer! Since the assignment is due today, Tyler is running out of time. Let's see if we can help him. Let's start off with what information Tyler does know. There are 4 sports to choose from: basketball, kickball, football, and soccer. Tyler knows that JK likes to kick the ball, but does not like kickball. He also knows that JK, Lisa, and Susie do not play the same sport as Bill. And Bill plays a sport that starts with the first letter of his name. Lisa enjoys kicking the ball, but never scores goals. And Susie is not a fan of kickball and soccer. Oh yeah, and JK's mom does not let him play football. Whoa, that is a lot of data to consider. How can we help Tyler figure out who plays what? What are some strategies that he can use? One of the best and easiest strategies is drawing a picture or making a table, like so. Tables are a simple way to organize information and help us narrow things down. Now that we have a table with the sports and classmates listed, we can consider the clues that Tyler has and draw an X every time an option is eliminated. Since JK kicks a ball but does not like kickball, Tyler eliminates basketball and kickball. And he knows that Bill plays a sport that starts with the first letter of his first name, which eliminates kickball, football, and soccer. Since JK, Susie, and Lisa do not play the same sport as Bill, Tyler knows he can eliminate basketball as an option for all 3. Lisa enjoys kicking, but never scores a goal. So soccer and football are definitely out. And Susie does not like to play kickball or soccer. So those 2 are not options for Susie. And remember, JK's mom will not let him play football. So we can X that out too. Well, look at that. It looks like we helped Tyler figure out the answers. Bill plays basketball, JK plays soccer, Lisa plays kickball, and Susie plays football. What a cool way to use our critical thinking skills to solve a problem. How would you solve a problem like this?
And that's why in 2011, I founded the country's first academic office specifically devoted to the teaching of critical thinking, and why I eventually founded the Critical Thinking Institute. I set myself what was a rather humble challenge, a simple ambition, if you will, all I wanted to do was figure out how to teach everybody in the world how to think critically. Yeah, I know. That's it. I also have other humble ambitions. I like tilting at windmills, and someday think the New York Giants might win another Super Bowl. But that was my goal. I wanted to teach everybody how to think critically, from kids through teens to adults, through kindergartens and college classrooms and corporate boardrooms. So what is this thing that we call critical thinking? Well, this is just a short list of all the things that critical thinking is. Or in fact, this is just half a short list of all of the things that critical thinking is. And I'm sure that all of you could make meaningful additions to this list because it goes on and on and on. With that being the case, how in the world can we teach a human being to do all of these different things well? Well, before we get to that, let's see, how well are we doing with critical thinking? Well, the Stanford History Education Group did a study of how well teens could think critically while they were online. Their conclusion, and I quote, "Young people's ability to reason about information they see on the internet can be summed up in one word: bleak." Don't kill the messenger. And the Wall Street Journal, upon surveying critical thinking outcomes of college students, came to the following rather stark conclusion. Even at some of the most prestigious flagship universities, test results indicate the average graduate shows little or no improvement in critical thinking over 4 years. I know. And if you want to see just how bad it gets, when researchers had college students wear portable brain monitoring devices for a week, they found, as you would expect, varying degrees of brain activity depending upon what the students were doing, whether they were studying or eating a meal or socializing. But the place they consistently found some of the least brain activity was when students were in class. I'm sure that's a wonderful statistic for any of you who are currently putting someone through college. So I wanted to find out why. Why are our critical thinking outcomes so low? And I cannot begin to enumerate for you all of the problems we found with our critical thinking instruction. It would take far too long. I need a lot of TED Talks to accomplish that. But I can share with you our number one reason. Something that no one had solved for it, and something that challenged us in what turned out to be a decade-long project. We referred to it as the sandbox problem. See, even in the simplest of sandboxes where we have children playing, there are an array of complex critical thinking tasks at work. Well, who's going to get the shovel? How are we going to get this sand out of our shoes? How do we get this other kid to stop throwing sand in everybody's face? What game should we invent? What should the rules be? And why again is it that we're not allowed to play in the yellow sand? And that's just the simplest of sandboxes in which we begin, not the metaphoric sandboxes of our lives, sandboxes that obviously become infinitely more complex as we enter adulthood and grapple with the challenges of the real world. In fact, as we take a look at our list of critical thinking skills and we overlay our sandbox on top of it, we find so many of these already present in the simplest of sandboxes. Well, they're problem solving, perhaps about how to move the sand. They're innovating games and ideas. They're arguing, perhaps, over who gets the shovel. In this case, they're inquiring about what other kids think they should do and why. And the list could go on and on. So the sandbox problem for us became as this. Given the complexity of even the simplest sandbox, of all of the critical thinking acts that are taking place in even the simplest sandbox among kids, how do we simplify the teaching of critical thinking enough so that everyone in the world can learn it easily without undermining the complexity of critical thinking itself, the complexity that we see in even the simplest of sandboxes? Whew. Well, that challenged us for years. And whatever research we did, we couldn't find anyone that, to our satisfaction, had solved for this sandbox problem, simplifying the teaching of critical thinking without undermining the complexity of critical thinking. Well, then I had an idea. it occurred to me that if we were ever going to solve the sandbox problem, we would only be able to do so if we relied on how the human brain evolved.
Year is 1968. We're at the Olympic Games in Mexico City. Dick Fosbury has just made a record-breaking high jump, winning the gold medal and completely changing how future athletes approach the high jump. But let's rewind and see how critical thinking played a part in getting Fosbury here. For years, high jumpers used a variety of techniques, all of which allowed for the jumper to land on their feet after clearing the bar. Athletes assumed that these were the most optimal methods. But in high school, Fosbury tried them and found himself getting below-average results. So he asked himself, how else could I jump over this bar? Instead of accepting the norm, he began experimenting and came up with a new and different jumping method. He would jump and rotate in the air so that he went over the bar head first on his back. At the time, he was laughed at and criticized for this new method. It looked pretty silly and was so different from the typical methods. But it worked due to some unexpected benefits. It lowered Fosbury's center of gravity, actually placing it below the bar even though he himself was jumping over it. This allowed him to use less energy while increasing his height. And by leaping backwards, he was reducing his chances of knocking the bar off with his arms and legs. Using this technique, Fosbury was jumping higher than anyone else on his high school track team. He continued to hone this method in college and moved on to qualify for the Olympics. And so here we are, back in 1968, with Fosbury winning the Olympic gold medal. He took a problem, not being able to jump particularly high, and used critical thinking to come up with a solution, a new way of jumping that greatly improved his results. To this day, almost every high jumper uses this method, now known as the Fosbury flop. And so it just goes to show how critical thinking can both raise the bar and change the game.